Yeah, good morning, everyone. Welcome to my PPT. My name was Bhuvaneshwar. Belongs to Computer Science Engineering Department in Institute of Aeronautical Engineering. Yeah, yeah. If your roll number, my roll number was 21951a0527, which you can see on my screen. This was my roll number. This is PPT belongs to the subject of applied physics. Like we are going to discuss and this whole PPT is going to about the topic of failures of wave theory. Yeah, I'm going to discuss about the how wave theory was failed. Like the points to remember about the points which leads to the failure of wave theory. I'm going to discuss these points which leads to the failure of wave theory. Yeah, we will go into the next slide. In this whole PPT, I am going to cover each and topic which was mentioned here. First, I will give a brief like prerequisites or introduction for the topic. Without prerequisites or introduction, it's a completely waste of even my time. Like without knowing the introduction or without knowing the basic idea about the topic, that's why I will give some point of prerequisites to the topic. Later, I will move to the explain the light wave theory, and next I will explain how light wave theory was failed in the respect of different terms of intensity problem. Like these are the problems occurred in the wave theory. By discussing each and every point related to this, we'll specify how wave theory was failed, and we will discuss the failure of wave theory. Next, next I will discuss the steps leads to the Einstein's quantum theory due to the failures of the wave theory. Like Einstein figured out or pointed out the failures of the wave theory and formulated a new quantum theory. And when the photoelectric effect is in continuation of due to the drawbacks of the wave theory. So we even discussed at last like how can we solve the failures of the wave theory of light. Yeah, introduction. This is a brief introduction. I won't even take more than 1 minute to introduce this. In the late 17th century, scientists were embroiled in the debate about the fundamental nature of light, whether it was in wave or particle. Sir Isaac Newton strongly advocated the particle nature of light. Like Isaac Newton was in the favor of the particle nature of light by showing some experiments, but later it was proven wrong. But first Newton considered it was light was in the form of the particles. But Dutch physicist Christian Huygens believed that light was made up of waves. Like Huygens is the father of waves, right? He first considered light as in waves vibrating up and down perpendicular to the direction of wave propagation, and therefore formulated way of visualizing the wave propagation. This become known as Huygens principle. We know Huygens principle. If you take any wave, every point on the wave acts as a wave font for the another producing the waves. This is the basic Huygens principle, I think. Yeah, I will show that like see, you can see on my screen. If this is a wave, each and every point on the screen, like here, every point occurs wave front for the another waves front for the another wave front for the another. Here and here, every point on the wave, this 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 wave, and each and every point on the each wave front acts as an wave for the another. Yeah, this is the basic idea of the Huygens principle. As I know which I studied in earlier, this is the basic principle of Huygens principle. You can see on my screen. Now let me introduce the light wave theory. First, if you want to know the failures, you should know the topic. Right? Let me introduce the wave theory of light. Light wave theory, or wave theory of light, or light wave theory, anything was same. Most of the times, light becomes as a wave categorized one of the electromagnetic wave. Like most of the light we treat as a wave in the form of electromagnetic. Electromagnetism means just if the electronic wave and the magnetic wave which moves perpendicularly 90 degrees to each other, where crust and thrust of the electric and magnetic waves won't match, then perpendicular direction which propagates in the perpendicular direction is called electromagnetic waves, because it is made of electric and magnetic field. Because electromagnetic is basically formulated by electric and magnetic field, right? Electromagnetic fields perpendicularly oscillates to the direction of the wave travel and the perpendicular to each other, as a result of which they are known as transverse waves. Yeah, these are moving particle vibrates in direction, wave propagates in another direction, right? So we can simply justify it as transform waves. A few characters of light are as follows. Let us discuss a few characters of light as follows. While dealing with the light waves, we deal with the single waveform. The period of waveform is one full of 0 to 360 degrees sweep. Light waves have two important characteristics known as wavelength and frequency. Light waves have wavelength and frequency. Even we know the relation between the wavelength and frequency as lambda in wavelength into frequency gives the speed of light, right? Frequency, which can we just simply increase 1 by t, lambda 1 by t, distance by time, which gives the speed or velocity is same. Frequency into wavelength, which result in the speed of the wave or speed of the wave. The distance between the peaks of the wave is known as wavelength. Yeah, if you want, see, if you consider a straight line, if you take this as a wave, this is one peak, right? This is one peak. The distance between the two peaks, from here to ending here, this is one peak, this is one peak, this is one peak, this is one peak, this is like, if you take two, as I forgot to mention, you should take two consecutive peaks. If this is one peak, this is another peak, you should take two consecutive, whether this peak, or this peak, or this peak, or this peak. Take any two consecutive peaks, then distance between this peak to this peak is known as wavelength, represented by lambda. Distance between the two consecutive peaks is known as lambda wavelength. And the wavelength is an order nanometers, so we can even most times, so we consider it in the Armstrong units. Armstrong is just simply 10 power minus 10 meters. If in centimeters, it belongs to 10 power minus 8. But we use Armstrongs as an units of light in the most times. Yeah. See, light wave theory. This is the light wave theory. See here, you can see that this, suppose this is an electric field, this is magnetic field, which are in perpendicular. See, blue lines and arrow lines are perpendicular 90 degrees, right? If you can see here 90 degrees, which are moving perpendicular in direction, produce an electromagnetic wave propagation. You can see on my screen. And hence the frequency is number of waves oscillating at a point. Just frequency is the number of waves crossing past at a point in a second. Frequency, like number of oscillations, number of waves crossing per point. These are many definitions for frequency. We used to represent frequency by using mu or f. Yeah, in wave we will use mu. Musical just 1 by t. Let me denote the relation between wavelength and frequency given by the equation. C is equal to lambda mu. You can see how C is equal to lambda mu. Later, the speed of light in the vacuum is universal constant. Yeah, speed of light is constant, right? 3 into 10 power 8 meter per second. You can 3 into, yeah, C is equal to 3 into 10 in the vacuum, not specifying the direction. In the vacuum, it is 3 into 10 power 8. Yeah, now see the wave theory. Let us see the wave theory of, right? As proposed by Einstein, light is made of packets of energy known as photons, like h mu. H mu is a one photon packet of energy. As proposed by Einstein, light is made of tiny packets of energy known as photons. The formula devised by Planck determines the energy of photon, and it also shows that the energy is directly proportional to the frequency of light. E is equal to h mu, where mu is the frequency. We can say that energy is directly proportional to the mu, where h is the Planck's constant value of 6.63 into 10 power minus 34 joules per second. You can also see on my screen of the diagram. Yeah, this is the wave nature of the light wave theory. Now let us consider the failures of the wave theory of light. According to the classical wave theory, intensity of wave is the energy incident per unit area per unit time. Energy carried by a electromagnetic wave is proportional to the square of amplitude of the wave. Classical wave theory can't explain the first three observations of photoelectric. Later we will see what are the observations of photoelectric effect, but classical wave theory could not explain the three observations of photoelectric effect. Like, first failure of wave theory was its like existence of threshold frequency. It does not provide any evidence for the existence of threshold frequency. See, since energy of an wave is dependent on the square of its amplitude, yeah, we can see in the classical wave that energy of every wave is dependent on the square of its amplitudes. The classical wave theory predicts that it's sufficiently, if sufficiently intense light is used, the electrons would absorb energy electrons through energy to escape. There should not be any threshold frequency. Like they did not. If we supply more intensity of light, like they described the not in the terms of frequency of light or wavelength of light. They just described about the intensity of light, where it doesn't play any role in the photoelectric effect. Like if we increase the intensity of light, if the threshold frequency was not there with the wavelength of the light, the ejection of electrons won't happen, right? Intensity of light just depend shows number of electrons should be ejected, not whether the electron is ejected or not. This is the major failure of the wave theory of light. You can see, since the energy of the wave is dependent on the square of amplitude, the classical wave theory predicts that the sufficient light is used, then electron would absorb energy to escape. There should not be any threshold frequency. This is the major drawback of one of the major failure of the wave theory of light. And next, almost immediate emission of photoelectrons. Like even this is the one of the major failure of the wave theory of light. Almost immediate emission of photoelectrons. Based on classical wave theory, the electrons require a period of time before sufficient energy absorbed from it to escape from the metal. Accordingly, a dim light after some delay would transfer sufficient energy to electrons for ejection, whereas a very bright light would eject electrons after a short while. However, it did not happen the full travel. Like basically, wave theory assumes that after some time of light falling on the metal, it will even this applies on the intensity phenomena. After some time, even low dim light may eject the electrons faster. High intensity light will eject electron faster, where this does not happen in the photoelectric effect. This is another one of the major drawbacks. Based on the classical wave theory, electrons required a period of time before sufficient energy is absorbed for it to escape from the metal. Accordingly, a dim light after some delay would transfer sufficient energy to the electrons to ejection, whereas a very bright light would eject electrons after a short while. However, it did not complemented the wave theory photoelectric effect. Now, the dependence of kinetic energy on photoelectron on intensity and the dependence on the frequency. According to the classical wave theory, if light of higher intensity is used, the kinetic energy of ejected electrons can be increased. This is because of the greater intensity. The larger the energy of the light wave striking the metal surface, so electrons are ejected with greater kinetic energy. However, it can't explain the why maximum kinetic energy is dependent on the frequency and independent of, like, it's basically blindly showed that intensity of may reflect on the kinetic energy of the electrons ejected, where that doesn't happen. It does not show any relation of the frequency with respect to the frequency of the light. Just it's blindly followed the frequency of kinetic energy of light was achieved from the intensity of light used, not the frequency. This is another major drawback of the wave theory of light. Classical wave theory, if light of a higher intensity is used, the kinetic energy of an ejected electrons can be increased. This is because the greater the intensity, the larger the energy of light wave striking the metal surface. So electrons are ejected with greater kinetic energy. However, it can't explain why maximum kinetic energy is dependent on the frequency and independent of the intensity. This is the most considered drawback of the wave theory of light, which leads to the path to photoelectric effect or Einstein packets of energy theory, like HV is equal to HV, which leads usually steps to the Gauss theory, Planck's constant theory. These are the these are the other failures of wave theory of light. First, intensity problem. According to the wave theory, intensity of wave is I is directly proportional to E naught square, right? I is directly proportional to E naught square, and so forth So force on electron E naught is equal to E mu naught, like E naught is an electric field. Acceleration and hence kinetic energy of electrons must increase with intensity. However, experiments show that Kmax is independent of intensity. Frequency problem. According to wave theory, photoelectric effect should take place for all frequencies, provided that intensity of light is sufficient to supply necessary energy to the electrons for its emission. However, experiments on photoelectric effect reveals that every metal that exists in frequency V naught, depending on the nature of metal, below which no photoelectric effect takes place. How the intensity of light. And this is related to the before point of intensity. Just without having threshold frequency, it's the electron won't eject from the metal surface unless until you have threshold frequency, whether you take a large intensifying light or a very small intensity of light. Next time delay problem. As energy in wave is spread over the wavefront, it will be absorbed by all the electrons to accumulate radiation energy from their emission from the metal. And so according to the wave theory, there must be an measurable delay between incidence of light and emission of electrons. However, no much time lag has ever been declared experimentally. Now let us see Einstein's quantum theory of photoelectric effect. Photoelectric effect is in the of which particle nature of light, which contradicts light theory due to the failures of wave theory of light. Einstein formulated the particle nature of light. Above all clearly shows that photoelectric effect and its characteristics can be accounted on basis of wave theory of light. Einstein's quantum theory of photoelectric effect. In photoelectric effect, it does not behave as a wave but as a particle called photons. Energy is an energy packet. Photon is an energy packet. Quantum of light energy with no charge and zero rest mass, which transfer energy is equal to h mu. Here h is a Planck's constant. Mu is the frequency of the light taken, where P is equal to E by C. Photon electric effect is a result of one to one inelastic collision between the photon electrons in which photon is completely absorbed. So if an electron is in metal absorbs a photon by energy h mu. Here, when photon is incident on the metal surface, it transfers complete energy to the electrons. Some part of the energy is used to bring electrons at the surface, and rest of energy is used to increase the kinetic energy. As we know, photoelectric effect clearly that Ek is the maximum kinetic energy, W is the work function of metal, h mu is equal to energy absorbed by the metal. For conservation of energy, h mu is equal to work function plus kinetic energy. Kinetic energy is equal to h mu minus work function. H mu is an intensity of h mu is the energy of light which you taken. Work function is used by the metal surface to bring the electron into the next medium. The difference in this will result into the kinetic energy. If you take work function as h mu naught, then we take Ek is equal to h mu naught. Let us represent kinetic energy of half max square. H is equal to h mu minus mu naught. Then mu naught is stopping potential. Then we consider mu naught the stopping potential frequency. This is known as Einstein photoelectrical equation and explain the photoelectrical effect. Like this whole setup explains the Einstein's photoelectric effect and which leads after the failure of wave theory of light. Yeah, thank you everyone. Thank you for yeah. Before in this whole PPT we discussed many topics. I given the introduction to wave theory. I discussed basic introduction prerequisites, and I discussed some properties of wave and light, and I discussed Huygens principle and failures of wave theory of light, and the path which leads to the failure of wave theory of light, and new inventions of the failure of light as in base trips, and everything in this whole PPT. So I think so. Hope so you got something. If you want to download my PPT, you can follow the description and you can take the PPT. Thank you everyone for this listening to the PPT. Thank you.